Okay, so we're going to solve systems with Cramer's rule. There are different ways to solve systems with matrices. There's Gaussian elimination. You can do it with inverses. You can do it a lot of different ways, but I just picked one so we could see that there is one way to do it. And so we have a linear system, and with this system of equations, we could do substitution, or we could do elimination, or we could do matrices, right? And it all just kind of depends on what you need it for and what you're doing. So from a linear system, if they're written in standard form, or basically the form you would use for elimination, then you set them up like this. So it's x, then y, then equals your constant. And we have what's called a coefficient matrix, which would look like this. You literally take the coefficients, which are just the numbers in front of the variables. And this is a 1 and a -5 and a -7 and a 2. Okay. Just the coefficients. The other matrices that we have are, we're going to write them over here because there's not a place for them. We have the variable matrix, so like the x and the y. This would be our variable matrix. And then we have our 9 and our -30. And that would be our constant matrix. Okay. So when we look at this, so it says Cramer's rule, named after the Swiss mathematician Gabriel Cramer, used the coefficient matrix and determinants, which we did the other day, to solve a system of linear equations. So then here it is generalized. We've got, instead of having numbers like we did right there, the A, B, C, and D represents our coefficients, right? And then so if we have our coefficient matrix, which let's write this up here. So our coefficient matrix A, C, B, D, if we multiply that times our variable matrix, X, Y, then that will equal, so if I have this is a 2 by 2 matrix multiplied by a 2 by 1 matrix, what size is my final matrix going to be? 2 by 1, good. So that ends up giving me my constants, which is 9 and -30 here, but E and F here. So think about how you multiply a matrix, right? I'm going to take AC and multiply it by XY. So that would give me A times X plus C times Y. Oh. I totally did that wrong. Wait, that's not right. Hang on a second. Here's why I know that's not right. Now that I second guess, this right here is what is wrong. We need to fix that. This is B, this is C. Okay? And I figured that because when you multiply them, what's supposed to happen, A times X plus C times Y, but that's not what they have written here. Goodness gracious. So if you don't have a pencil, yeah, that's not right at all. So now if I do AB times XY, A times X plus B times Y is going to equal that E. That's what's happening here. You're getting this back. Okay? Only if it's written correctly, because it wasn't written correctly. It wasn't typed in correctly. I'll take credit for all my mistakes because I make them all the time. That one was actually not mine. All right. Everybody okay so far? Okay, because it really does, the letters don't really matter. I was just trying to show you how it works. Okay, so here's how we use that to be able to find this. Remember this thing that looks like the absolute value? This is actually the determinant. So we need the determinant for the coefficient matrix, and then we also need the determinant for these other little matrices that we make up. So look at what's happening here once this is actually written correctly. When I make so this is the determinant of whatever this coefficient matrix is. Then I make a new matrix. If I'm looking for X, I leave the B and D, which went with Y, and in place of X, I put the E and F. And then I do the opposite for here. And I'll hopefully make that make more sense down here. But you're basically finding 3 determinants. 1 from the coefficient matrix and 2 from matrices that you come up with. You're not making them up. They're just built by what you have here. Okay, so note if the determinant of the coefficient matrix equals 0, then the system does not have a unique solution. It has either no solution or an infinite number of solutions. Okay, so it's fun times when we get a determinant of 0 because then we get to stop. All right, everybody with me so far? I'm going to make all that nonsense up there make sense. My coefficient matrix, A equals, this is going to be 1, -5, -7, 2. Okay. There's my coefficient matrix. So then the determinant of A, remember to find the determinant of A, we multiply down, 1 times 2 is 2, minus, then we multiply up, that's a positive 35, that gives me a negative 33. Unfortunately, it is not 0, and we have to continue, okay? So I found the determinant of the coefficient matrix. Now, in order for me to find X, I'm going to use this negative 33. And I'm going to put what looks like absolute value signs because this isn't a matrix. This is going to be, I'm going to find the determinant of this. Since I'm looking for X, remember your first column is like your X's, your second column is your Y's. We replace the X's with our constants, so 9 and negative 30, and we leave the Y's in there. Do you see where that came from? All right, so I'm going to leave negative 33 down here. Then I'm going to do 9 times 2, which is 18, minus 30 times 5, which is a positive 150. So this is going to give me a negative 132 over a negative 33. And that means that, I'm going to put it over here so we have room, X equals 4 when you divide that out. Everybody okay with that? And you can use calculators on these to help you with the number. All right, so then we're going to do the Y part. So then Y equals, I'm going to have that negative 33 down here. And this time I'm leaving the X's, the 1 and the negative 7. And I'm changing the Y's to the constant, 9 and negative 30. So that's going to give me negative 33 down here. 1 times a negative 30 is a negative 30. Minus, what's 7 times 9? 63. Minus a negative 63, which means we're actually doing what? Adding. So I'm going to add that. I'm going to get a positive 33 over a negative 33. So Y equals 1. Negative 1. Negative 1. What questions we got? We good? Okay. Do we understand how to make the new things we're making a determinant out of? How to come up with these? If I'm looking for X, I take out these, because up here, look again, when it's actually written correctly. A and C, this first column goes with my X's. The second column goes with my Y's. So when I'm looking for X, I replace X with the constants. When I'm looking for Y, I replace Y with the constants and leave the rest from my coefficient matrix. All right, let's try another one. So I'm going to start off with my coefficient matrix. 0.2651. Everybody understand where those numbers came from? Yes. Okay. So then I'm going to find that determinant. I'm going to do 2 times 1 minus 5 times 6 gives me a negative 28. Any questions about where that number came from? We all got it. Now your time to ask. If you have no idea where something's coming from, you got to tell me. Okay. So now we're going to look for x. In the denominator goes this determinant, negative 28. Okay. In the numerator, I'm going to come up with what I'm going to find the determinant of. I am looking for x. I replace my x coefficients, 2 and 5, with these numbers, 38 and negative 3. And I leave the y values. Any questions about what I just did? Ask me now if you don't know where my numbers are coming from. Because I know, even if you're paying attention, you're looking up and looking down. All right, I'm going to move on then. So then I'm going to find this, and I'm going to get negative 28 in the denominator still. I'm going to multiply 38 times 1, that's 38, minus, always put the minus there first so you don't get the signs mixed up. Negative 3 times 6 is a negative 18, so I'm actually adding. And so when I add that, that's 40, what is that, 56? Positive 56 over negative 28. All right, so pause for just a second here. When we wrote our coefficient matrix, we found a determinant. This is one of the determinants, right? These little things that look like absolute values means we're finding another determinant. So this is another determinant from our little matrix we made up. You with me on that? Because in Delta Math, here's what it's going to ask you. It's going to ask you for 3 determinants in any order. It doesn't matter. And what it's talking about is as you're going through this, this is the first one that we found, and then this one that's on top before we divide, and this one that's on top before we divide. It's asking you for those 3, okay? Also, while I'm thinking about it, it looked to me when I clicked through questions, I mean, it's impossible for me to click through absolutely every single question, but when I clicked through a bunch of them, it looked like they don't really reduce very nicely. So expect some fractions. Expect to maybe leave it like something like that or reduced a little bit. So don't let that freak you out. I know sometimes when we have nice, pretty numbers and then you don't, you're like, am I doing something wrong? So just want to throw that out there. Okay, so then we're going to find, so when I actually divide then, what does x equal? Negative 2. Okay. Then we're going to find y. See if you can set up what you need to take the determinant of in the numerator without me. Do you agree with what I have written so far? Just got to make sure we get the numbers in the right place. Okay. Then you go ahead and see if you can finish this one up. I'll make you multiply and everything. So the 3 determinants that we found, negative 28, 56, and negative 196. Okay, when you divide that, it becomes 7. Now, when you find the answer to a system of equations, what is the proper way to answer them is in an ordered pair fashion, like 4, 1, negative 2, 7. I don't recall what Delta Math had you do. I just remember that they asked you for the 3 determinants first. Okay. What questions do you have? Do you want to do the third one? Do we need to do it? Yes? No? Anybody? Yes? Okay, let's do it. All right. Let's do it. I don't mind. I mean, I'll stand up here and work questions all day long. I just don't want to. All right. So we're going to start with our matrix, our coefficient matrix. And then you go ahead and you find this determinant. Without just copying mine. And then we'll check it. Nope, nope, nope. Nope, nope. I was just about to look up there and ask you if you agreed. Hopefully you did not, because I totally made up numbers. What the heck? I caught myself when I looked up there, though, so that's something. -12 minus a -3. -9, do we agree with that one? Yes. Whew. Okay. All right, then you set up the first step for x. And let's make sure we agree on the setup before we do anything else. Okay, so remember we replace the x's with our constants from over here, leave the second column. We agree with that? Awesome. And if you want to go on and just finish it, you can, but I'm going to kind of step by step for the people that need it. This is going to give me 4. Now I don't even trust myself to subtract. And then I'll set up my y, so if you want to check your setup before you continue, you can. Any questions about any of my numbers, which I'm pretty sure are correct at this point, but you never know. Okay, so it's fine. So these steps right here, like if you're using a calculator and so you're multiplying and subtracting and jumping from here to here, that's okay. Just remember that you're going to be asked for each of these determinants. So you have to have these 3 numbers plus the answer when you're done, okay? What questions do you have? Feel a little bit better about it? We're good? We can do this, right? Okay.